In this section, we will continue learning important JavaScript fundamentals. And so that means that we will learn the basics of functions, objects, arrays, and also loops. So after this section, you will already have a good foundation to start writing your own small programs using the power of JavaScript. And I hope that sounds super exciting, and so let's get started. Now, before continuing to learn JavaScript in this new section, we should first activate a special mode in JavaScript called strict mode. And here on my desktop, I already have the folder for this Part 2 Fundamentals section. And for you, as I explained before, these starter files will come from the GitHub repository that I showed you at the beginning of the course. So use that GitHub repository as your starter folder, or of course you can just copy that data somewhere else to your computer and work from there. Whatever works for you. Now I'm creating here a new VS Code window. And let's open this new folder. So that's our new working folder. And this time we already have the script file here. And in the HTML file, we see that the script is also already linked. So we don't have to do that this time. At this point, I assume that you already know how to do that. So closing the sidebar here, and let's now get started in this new section. And as I said, let's start with strict mode. So strict mode is a special mode that we can activate in JavaScript, which makes it easier for us to write secure JavaScript code. And all we have to do to activate strict mode is to write this string at the beginning of the script. So use strict, and that's it. So with this, we activated strict mode for the entire script. Now what's important is that this line of code, so this statement here basically, has to be the very first statement in the script. So if we have any code before this, then strict mode will not be activated. Comments are allowed because JavaScript will just ignore them, but no code. Okay, now we actually can also activate strict mode only for a specific function or a specific block, but I don't really see the point in doing that. And so I always just use it at the beginning of each script. And so I believe that you should do the same. So always just put strict mode in the beginning of your scripts, and like that, write more secure code. And with secure, I mean that strict mode makes it easier for us developers to avoid accidental errors. So basically, it avoids us to introduce bugs into our code. And that's because of two reasons. First, strict mode forbids us to do certain things. And second, it will actually create visible errors for us in certain situations in which, without strict mode, JavaScript would simply fail silently without letting us know that we did a mistake. Okay? So again, first, strict mode forbids us to do certain things. And second, it creates visible errors in the developer console, where in other situations, JavaScript would just fail silently. Okay, but now to make this a bit more clear, let's actually see an example of one of the most important changes that strict mode introduces. So let's create a variable here with a complicated name. Let's say has driver's license. And let's initialize it to false here. And then I also will create pass test and set that to true. And I'm using let in both of them because I want to change them later. And actually this one not. So let's just use a const here. Because remember, by default, we should always use const to avoid accidental errors. So basically there is a certain person which right now does not have a driver's license, but they just passed a test. That's why we have pass test set to true. And now we want to write some logic so that when they pass the test, this variable here gets set to true. So we can say if pass test, right? because this here is a Boolean value. And so this condition will be either true or false. And then let's introduce a simple bug here. Okay, so this is a kind of hard to write variable name. And so let's pretend that we are writing it wrong here. So has driver license equal to true. So what I did here was to basically omit the S. So this letter here is not in this variable that I'm trying to change here to true. And again, that is an error that I'm making here on purpose, just to show you how strict mode can help us avoid a certain kind of error. Because doing this is actually more common than you might think, okay? And now, then let's log something to the console if the person has a driver's license. And so now we're actually gonna go back to writing it correctly. So if has driver's license, and so you see that now this one is exactly the same, as VS Code highlights both. So if has driver's license, then log to the console, I can drive. And now let's actually start by deactivating strict mode again, just so we see how this bug could affect our code. So I'm giving it a save, and then let's go and open this index.html file. Okay, now let's open up the console here. And again, I'm going to increase the text by hitting Command plus a couple of times here. Okay, so let's reload here just to make sure that everything is working. And now what we see is that it didn't log I can drive to the console, even though we attempted to set has driver's license to true here. And so we expected that driver's license being true should then log I can drive. But it didn't work. And that's because of the mistake that I just introduced here on purpose for getting this S. So without the error, it should work, right? But without it, it's not gonna work. And again, because basically here I set a new variable to true and not the original one. So this one is still false, and that's why here this logging does not happen. So now our program has a bug, which means that it has a mistake, and we would now go ahead and find that bug. But strict mode can actually help us with this. So let's turn it back on, give it a save, and now try it again. And now we actually get an error. So here we see that has driver license is not defined. So in line number 6, which is right here. And so this error message now tells us exactly what is wrong. So it tells us that this variable is not defined. And then we can see, oh, we did a mistake here. We're missing the S, right? So now it's the same variable here, here, and here, okay? And so if we try that now again, then the error is gone. And so strict mode really helped us avoiding this kind of bug that we created here. And you can experiment a little bit with this to make it really clear. Now, another thing that strict mode does is to introduce a short list of variable names that are reserved for features that might be added to the language a bit later. For example, let's try to define a variable called interface. For example, for an audio interface. And now if we try this, then we see that we get an unexpected strict mode reserved word error message, basically. And that is, again, because JavaScript is reserving this word here for a feature that it might implement in the future. And so by reserving this kind of words, it will then make it easier to implement the feature in the future. So another one is private, for example. So const private, just some number here. And so this one will also not work. And that's because in the future, there might be something called private fields in classes or in some other places, even in the language. And they might want to use this word for that. And so strict mode reserves these words so that we cannot use them for variables. It's the same logic as this one. So we cannot call a variable if, right? And that's because there is already an if statement. So here we get unexpected token if. And so that's like the rules that I explained to you in the beginning about naming variables. Okay? All right. Now there are actually a lot of other changes that affect things that we haven't learned about yet. So that's stuff like functions, objects, setting properties on primitive values, and many more. And I will mention them in future lectures when the time comes. But everything that I'm gonna say in the rest of the course from now on will always assume that you have strict mode turned on. And so I will add this line of code here to all the scripts in the future, and so you should do the same. Anyway, with this out of the way, let's now start learning functions. The fundamental building block of real-world JavaScript applications are functions. They are one of the most essential concepts in the language, and so let's study functions over the next couple of videos. So, what actually are functions? Well, in the most simple form, a function is simply a piece of code that we can reuse over and over again in our code. So it's a little bit like a variable, but for whole chunks of code. So remember, a variable holds a value, but a function can hold one or more complete lines of code. So let's now declare our very first function. So we start with the function keyword, and then we define a function name. And let's now just create a simple logger, which is a function that will simply log something to the console. So I will call this one logger, and then we need parentheses, and we will see why in a next example. And then we use the curly braces to create the so-called function body. So all the code that is within this code block here, so within this block of curly braces, is called the function body. And it's this code that will be executed when we run this function. So let's say we needed to execute a log many times somewhere in our program. So let's simply console.log, my name is Jonas. And so somewhere in our program, we needed to reuse this line of code here multiple times. And so that's why we put it in a function. Okay? So we created the function, and now we can use it. And we can use it as many times as we want. So to use the function, we simply write the function name, followed by parentheses, and that's actually it. And this process here of basically using the function is called invoking the function, running the function, or calling the function. So let me actually write these terms here. So calling, running, or invoking the function. And you will see me use these three terms here interchangeably. Okay, so they basically mean the same thing. You can think of them as like executing or using the function that we defined previously. Okay, and as I said, we can now use or call or run this function as many times as we want. And each time that we call the function like this, then the code that is in the function will get executed. All right, so in this case, what should we expect here? Let's see. And indeed, we get this my name is Jonas log 3 times because we called the function 3 times. And so this line of code here was executed 3 times. Great. So we just wrote our very first function and it's already working just fine. And I hope that this logic of reusing code makes sense to you. But let's now take it to the next level and really use some more functionalities of functions, because they can do a lot more than simply reusing a line of code like we did here. So usually when we write functions, we also pass data into a function. And additionally, a function can also return data as well, which means to give us data back that we can then use for something else in the program. So a function can not only reuse a piece of code like we did here, but it can also receive data and return data back. And so I like to think of functions as machines. So I think that's a great analogy. So for example, let's imagine a food processor. So we put food into the processor, then the processor does something to our food, which is the function body basically. And then in the end, the food processor returns the processed food, for example, a juice. And so that's exactly what we can do with functions as well. And actually, let's implement exactly this example. So again, we need to use the function keyword, and then we choose a function name. And just like with variable names, we should choose descriptive function names so that we know exactly what they do. So let's call this one a fruit processor. But in this function, we also specify something called parameters. And parameters are like variables that are specific only to this function. And they will get defined once we call the function. So let's give this fruit processor function 2 parameters, apples, and then a second one separated by a comma called oranges. And again, these two will get defined once the function is called. And they represent the input data of this function. Okay, and this will make even more sense when we then actually call this function. And let's start by logging these to the console. So apples and also oranges. And so what I'm doing here is to basically use these parameters here, so apples and oranges, just as if they were normal variables here inside this function. And now let's actually do something more interesting with these parameters. And so we want to kind of simulate that this fruit processor produces a juice out of the apples and oranges that we give it. And so let's just create a string which says that. So I'm going to create a variable called juice and then a template literal. And I'm going to say juice with, and then I'm using actually the apples parameter here. So apples, and then apples, because this apples parameter will be a number once we call this. For example, if we set apples to 3, then the string will be juice with 3 apples. And again, this will really make sense once we call this function. So oranges and oranges again. Okay, so here we build a string using the input data that we get into the function. And now comes the really cool part, because now we can use the return keyword. And with this, we can return any value from the function. And so let's actually return the juice that we just produced. And so this value that we then return can be used anywhere later in our code. So basically, this juice will become the result of executing this function. And let's actually do that. So let's call or run or invoke this function now. So fruit processor. And now we're going to specify the actual values for the parameters apples and oranges. And so let's say, for example, 5 apples and 0 oranges. Okay, and so these now will be the inputs of the fruit processor function. So you can think of these parameters here like empty spaces that we still need to fill out when we are writing the function. And when we call the function then later in the code, here at this point, we then fill these blank spaces by passing in the real specific values, which will then get assigned to the parameters. In this example, apples will become 5 and oranges, which is the second parameter here, right, will become 0. And these actual values here of the parameters are called the arguments. All right, so let's now basically run this script. And so now we get 5 and 0. So this is coming from line 26, which is this line. So it's this logging to the console of the apples, which is 5, and oranges, which is 0. And apples are 5 because that's the value that we specified here. Okay? So we specified apples as 5, and so in this function, the apple parameter, or you can think of this parameter as a variable, is now 5. And oranges is of course 0. But now you might wonder, what about the juice that we just produced here? Where is it? Well, the juice was returned from this function. So basically that means that the result of running this function here is the juice that we just returned. Basically, once this function has been executed, this code here is then replaced by the result of the function. And in this case, that's going to be the juice string that we produced. So if we want to use that value that was returned, we need to store it in a variable. So let's do that. So let's call it apple juice. And then let's log that to the console. Reload it here, and now we get juice with 5 apples and 0 oranges. So let's recap again what happened here. So we called the fruit processor function here with 2 arguments, 5 and 0. And these arguments are the specific, so the actual values of the function's parameters, which are apples and oranges. And so when the function is running now, apples in here will be 5 and oranges will be 0. Then we use these values to build this juice string here, and then we return that value from the function. And what that means is that basically the result of calling this function here will be the juice value that was just returned. Okay? And then we need to save that value somewhere. We need to capture it. And we do that by basically saving it into this apple juice variable. And then we can simply log that value to the console. Of course, we could have also directly logged it to the console. So basically without capturing the value anywhere and simply logging it. So let me just copy this one here. And so if I run this now, we should see the same string twice. And yes, indeed, now the fruit processor function was executed twice, once here and once here. The only difference is that in this case here, we did not capture the value into any variable. We simply logged the result of running this function to the console directly. Okay, so just to show you the difference. Okay, and now thanks to the power of the function, we can reuse the function with different input values and then get a different output. So let's try that, and let's create a apple and orange juice. So apple, orange, juice. And so this time we can call fruit processor, let's say with 2 apples and 4 oranges. So once again, we are defining specific values here, which are the arguments, which will get passed into the function here as these parameters. So essentially what we did here was to create a very generic function that works for any number of apples and oranges. So it's really like we're leaving apples and oranges as the blank spaces. And then when we call the function, we fill in these blank spaces using our arguments. So 2 and 4 in this example. And now we can also then log the result. So apple, orange, juice. And actually we can get rid of this console.log here because we don't really need it. All we want here is to produce this juice and then return the juice from the function. Okay, and so now we get 2 juices, one with 5 apples and 0 oranges, which is this first one, and then finally the juice with 2 apples and 4 oranges. And so that's the second one that we just produced. And of course, we could run this function as many times as we wanted. But we should call it at least once, because if we never call the function, then the code that's in the function will never be executed. And that makes sense, right? So without executing the function, it's kind of useless, because the code will never run. it will never be processed because that only happens once we call the function like this. Or like this here also. So as you see, this function here has no parameters. And so here, when we call the function, we do not specify any arguments. We could do that. So let's just pass 23. But since there are no parameters, it will not get used. And so specifying the argument here or not will not have any effect. You see that this function here also doesn't return anything, and that's not a problem at all. Not all functions need to return something, and not all functions need to accept parameters like the fruit processor that we have down here. So this is a very simple function here, and this is a more complete example showing you everything that we can do with functions. And this kind of function is actually way more usual than this simpler one here. So a function like this without parameters and without a return, we really only use when there's a block of code that we want to reuse over and over again. Once more, keep in mind that this function does not return anything. All it does is to log something to the console, but that has nothing to do with returning a value. This really only prints a message here to the developer console, but it doesn't return a value. So basically, this here does not produce a value because we don't return anything from the function. And that's why here we also don't save the result of the function to any variable, because it doesn't produce any result. Well, technically it does produce undefined, but that's not really relevant here. And so of course we don't capture that undefined value. Okay, great. And that's basically the fundamentals of functions. And I'm pretty sure that this was confusing for you if this was your first contact with functions. And actually, that's probably how it's supposed to be. So what I want you to do is to review this lecture very thoroughly and really understand how all of this works together. So how writing this generic function with the parameters works together with then calling the function with the specific values, and how the function then returns a value, and how in the end we then receive that value here and capture it into this variable. So that's what I want you to think about and to analyze. All right. So as a conclusion to this lecture, we can say that functions allow us to write more maintainable code, because with functions, we can create reusable chunks of code instead of having to manually write the same code over and over again. So that's the most important thing that you need to know about functions. And when you know that, you will know when you should actually use functions. And this is actually a very important principle for writing clean code that is used in programming all the time. And this principle is called don't repeat yourself, or dry. So we say that we should keep our code dry, which means that we should not repeat ourselves. And so functions are perfect for implementing dry code, because they are reusable code blocks that together make up our applications. And of course, we will use functions throughout the rest of the course because, as I said in the beginning, they are a fundamental building block of JavaScript programs. Oh, and by the way, you can now understand that console.log here is actually also just a function, but a built-in function that we do not have to write ourselves. But you see that we just call it like our own functions. So we call it using the parentheses here, and then we pass in a value. So apple orange juice. And the result of calling the function is simply this message then appearing in the developer console. And the same is true for the function that we used to convert a string to a number. So this is another built-in function that takes this 23 string in this case as a parameter. So we pass this argument into the function, and this function will then be executed and return the string as a number. And then we can save that like we did before. Okay, so this is going to work just the same. Oh, and of course we cannot see it, but we can still check it out by writing num. Okay, But now, anyway, I will leave you to really analyze how all of this logic here works that we just wrote. So do that now, and only once you fully understand how this example works, move on to the next video. Welcome back. So I hope that you studied the last lecture really well, so that you really understood what we did there with our food processor function. Now, in JavaScript, there are different ways of writing functions, and each type of function works in a slightly different way. But don't worry, they are still all very similar. So let's find out now. So the functions that I showed you in the last lecture are called function declarations, because we simply use the function keyword to declare a function, a bit like we declare a variable. So let's now write another function declaration, and this time a function to calculate an age based on a given birth year. So let's again use the function keyword, and we're going to call this one calc age1, and that's because we're going to have another one later. So as I said, we want the person's birth year as an input to this function. And what is an input? Well, it's just a parameter in this function. And a parameter, remember, is a bit like a local variable that's only available inside of this function. Then the function body with the curly braces, and now the code that we want to create here. So how do we calculate an age? Well, just like we did before, we take the current year, which once more, let's suppose it's 2037, and then minus the person's birth year. And then remember to take this value now out of the function, we return it using the return keyword. So we calculate the age first, and then we return that value. And actually we can simplify this and basically return all in one go. So there's actually no need to store this value here in a variable if all we do is then later return that value. So in fact, we can just take this value here, get rid of this, and then simply return the result of this expression here. So basically of this operation. Okay? So we're taking the birth year that we're going to receive and then use that to calculate the age. And so once again, this is a generic function which is then going to work for any birth year that we give it. So of course, let's now call or invoke or execute this function. And again, I can use all of these three words interchangeably. They all mean the same thing. So calc age1, and then remember to call the function, we use parentheses, and then we specify the actual value of the parameter, which is called the argument. Remember? So let's say 1991. Now some people use the words arguments and parameters as if they were the same, and actually that's not a big deal, but to be really precise, the parameter is, again, the kind of placeholder in the function, and the argument is then the actual value that we use to fill in that placeholder that is the parameter. Anyway, this will now create a value, right? And the value that this will create is the value that's returned from the calc age function. So basically this returned value. And so, once again, we need to capture or to save that value into a variable. So let's call this one age1. And just to make sure that it works, let's quickly check it out in the console. Okay. And indeed, we get 46, just like we did before. Okay. So that is a function declaration. But now let's create a function expression. So that's the other type of function that exists, and it looks like this. Instead of writing a function with the calc age name, we simply write function basically without a name, and then we still define the parameter. We still define the function body, which is going to be the same as this one. because we want another calc_h function here. So we write the function like this, and then what we have to do is to store all of this here into a variable. And that variable will then be the function. So let's call it calc_h2. So again, we did write the function in a very similar way, but we didn't give it a name here. So it's a function without a name, basically, which is also called an anonymous function. So all of this here is basically an expression. And remember that an expression produces a value. And so we use that value and store it into calc_h2. And this will then be the function. And I know that sounds very confusing, but it will make sense, trust me. Now, to call this function, we actually do it in the exact same way. So let's do h2 equals calc_h2, and let's use 1991 again. And then let's grab this console.log here and log both the ages. So h2 here. Let's also add some comments here. Function declaration and function expression. And so we should get twice the 46 value here. And yes, indeed. So the function expression works the exact same way as the function declaration. So we call it in the same way, we capture the returned value in the same way, and then of course the result is also the same because the function body is the same. But it's very important to know that we have these two types of functions in JavaScript, because in some places we will actually need to write them like this, as you will see as we go through the course. So again, this part here that I just highlighted, this function here is in fact an expression. And remember that expressions produce values. And so we just assign this whole value here then to this variable. And so this variable will then hold this function value basically. And one big implication of what I just said, so that this here is just a value, is that in fact in JavaScript, functions are actually just values. So just as a number or a string or a Boolean value. So a function is not a type, okay? It's not like a string or a number type, but it's also a value. And so if it's a value, we can store it in a variable. So just keep this in mind because it will become very important later when we really dig deep into functions. Now, besides these technical differences, you might be wondering, what is the big deal? So what's the big difference between function declarations and function expressions? Well, the main practical difference is that we can actually call function declarations before they are defined in the code. So let me show that to you. So here is the declaration, right? This is the function declaration. And as I just said, we can call them in the code before they are defined. So now we're calling it first and then defining it later. So let me show you that that still works. And indeed, we still get the same result. But if we attempt to do the same with the expression, then that should not work. So let's see. And yeah, so cannot access calc_h2 before initialization. Okay. And internally, this happens because of a process called hoisting, but more about that in a future section. Okay. For now, just keep in mind that you can call a function declaration before you define it, even though that might not be such a good idea in many cases. But you can do it if necessary. All right. Now, another question that you might have in your mind is, which of the two types of functions should I use when I write my own functions? And, well, the answer is that oftentimes it's really just a matter of personal preference. And so different developers prefer different formats. Personally, I prefer to use function expressions, because this then forces me into a nice structure where I have to define all the functions first at the top of the code and only then I can call them. So this makes the code a little bit nicer and more structured. I also like to have everything stored in variables, so both values and functions. But again, that is just my own personal preference, and many other developers don't agree with this and prefer to use function declarations. So if you also prefer function declarations, that's fine. So just use declarations then. It's absolutely no problem. However, even if you prefer one over the other, you still need to know about both the function expressions and function declarations. So you cannot just pick one and then forget the other one, because both have their place in JavaScript. And so it's really important that you know how to use and how to distinguish both function declarations and expressions. So we learned about function declarations and expressions in the last video, but there is actually a third type of function that was added to JavaScript in ES6, and that's the arrow function. And an arrow function is simply a special form of function expression that is shorter and therefore faster to write. So let's actually get back this function expression from before here, so from the previous lecture, just so that we have a comparison, so like a reference point. And so now let's write the arrow function. And this is how we write an arrow function. So again, we want the birth year because we want to calculate the age again. And then we write an arrow. And that's the reason why this function is called arrow function. And then we simply write what we want to return. So in this case, that's 2037 minus the birth year. And that's it. Now to finish, we actually want to be able to use this function. So let's again store it in a variable, just like we did here with this function expression. So let's say const calc age3 this time, and then we set that variable to this function here. Okay? So as I said, this is a special form of a function expression because it still is a function expression actually. So it's a value, all of this, that we assign to this variable. So just like this function expression up here. But this one, as you see, is a lot easier and faster to write. The first reason for that is that we don't need the curly braces, like we have here to define a code block. And second is that the return actually happens implicitly. So this value here will automatically be returned without us having to explicitly write the return keyword. Okay? So this is excellent for simple one-liner functions. And you will see throughout the course that this is going to be extremely helpful in certain situations. And now to use this function, it of course works the exact same way as using all the other functions. So we call calc age3 just like we called the other calc age functions. Okay. And again, we save the returned value here to a variable. And then let's just check it out here. And so this one should be 46 again, just like we had in the previous lecture. And yeah, it works. So indeed, the value that we calculated was returned automatically without us having to write the return keyword. And you see that here we also didn't need any parentheses or anything like that. Just this here is the function. Okay? Now this is actually just the simplest form, which is when we only have exactly one parameter and only basically one line of code in which we want to return something. But it gets a little bit more complex when we add more parameters or more code. So let's now write another function, and we can get rid of this one since it was just a copy anyway. And so let's say that we want to calculate how many years a person has left until retirement. So let's call this function years until retirement. And then we set that equal to a function. And once again, let's pass in the birth year. then the arrow again, but now here we need some more code. Because to calculate the number of years until the retirement based on the birth year alone, we first need to calculate the age, and then from there we need to calculate the retirement age minus the current age. So we need more lines of code, and so we are back to actually needing the curly braces in order to define a code block like this. So let's do what we just said. So calculate the age based on the birth year. So 37 minus the birth year. And now let's calculate the years until retirement, basically. And so let's say that the retirement age is 65 years, as it is in many countries, here in Europe at least. So 65 and then minus the current age. And that will then give us how many years we have left. And now to return this retirement, we actually need to write the return keyword explicitly. So we can only omit the return here in case we have a one-liner function like here. But if we have more, then we need to do the return still. So let's now run this function. So years until retirement, and then again some year. And then, as always, we could capture the return value into a variable. But this time, let's actually log that value to the console directly. So console.log, and yeah, so let's try that. And so it's 19. So, and that makes sense because 65 minus 46, which is the age, is 19. Okay, so that's the scenario when we have one parameter here and then more than one line of code, basically. And remember, in that situation, we need the return statement here. But now, what if we had multiple parameters? Well, then we need to wrap the parameters here into parentheses. So in VS Code, we can just select a variable and then write parentheses, and then it will automatically wrap this variable into parentheses on both sides. So let's say that we want the birth year, but also the first name, so that we can like return something else, like a sentence. So let's comment out this part here, and instead let's return a string. And again, we're using a template string here to build that string. And basically I want to say like first name retires in X years. So let's use that placeholder here. So first name retires in, and then we use that value that we just calculated. So retirement, give it a save here, and now we need to call it. And so let's add the second argument here so that it will go to the second parameter. So the first one here is of course birth year, and so that corresponds to 1991. And now the second argument will go to the second parameter, which is the first name. So let's say Jonas, and let's just call it twice, so that it actually makes more sense that we even put this logic into its own function. So let's say that Bob was born in 1980, and so let's see how many years he has left. So Jonas retires in 19 years, Bob retires in 8 years. Great. And that's essentially how the arrow functions work. You just need to keep in mind the couple of different scenarios that there are regarding to the number of lines of code that you need and the number of parameters. So as you add more code and more parameters, it gets a little bit more complex, and we kind of lose the advantage of using an arrow function. So now you might ask the same question as before. What type of function should I use? Should I use arrow functions for everything since they are so easy to write? And well, the answer is no, but it's also complicated. That's because there is another fundamental difference between the arrow function and more traditional functions. So function declarations and function expressions. It's the fact that arrow functions do not get a so-called this keyword. And this, once more, is a topic for much later. So remember that learning is not at all a linear process. And so topics need to build up on one another in an incremental way. Otherwise, you would just get super overwhelmed and super stressed if I were to tell you everything at the same time. So for now, we will actually keep using mainly the normal functions, except for very simple one-liner functions. For example, like this one here. And that doesn't mean that arrow functions are not important. They absolutely are, and I love them and I use them all the time. Sometimes I don't write regular functions at all. But again, you cannot yet understand all the implications of using arrow functions. So for now, again, we will keep using probably the function expressions the most. Let's now take functions even one step further and calling one function from inside another function. And this is something that we do all the time in JavaScript, but I have seen many beginners struggle to understand this logic. And so I created a specific video just for this topic. And to illustrate functions calling other functions, let's go back to our initial example of a function being like a food processor. So let's move to the first functions lecture, which is this one, and simply copy this function. So remember that we had this function, which was like a fruit processor, which received a certain number of apples and a certain number of oranges. And then based on that, it basically produced and returned a juice to us. But now in this example, let's consider that the fruit processor can only make juice with smaller fruit pieces. And so before making the juice, the food processor now needs another machine that first cuts the fruits that we give it into multiple smaller pieces. So I hope that's not an example too silly, but I think it makes sense actually to understand the point that I'm trying to make. So let's actually start by writing that machine. So basically that function that cuts a fruit into multiple pieces. So let's say function cut fruit pieces, and then this function will receive a fruit. And all this function will do is to return the fruit cut in 4 pieces. So basically, fruit multiplied by 4. So if we get 2 apples here, it will return 8 pieces to us. So simply the number 8. Okay, so that's our machine that cuts the fruit in pieces. And now here in the fruit processor itself, we receive the apples and oranges, and then we're going to use our newly created machine to cut the received apples and oranges into pieces. And so let's do that. So we start by calling cut fruit pieces in here with the number of apples that were received. And the result of calling this function, we will then capture into a variable called apple pieces. Apple pieces. Okay? And now let's do the same for the oranges that we receive. So orange pieces will be also cut fruit pieces, but we call it with the oranges. Okay? And so for the first time now, we called one function inside of another function. So if we now call fruit processor with 2 and 3, then this will call the fruit processor function, which then in turn will call the cut fruit pieces function. And actually twice, so once here and once here. And so let's now actually analyze how the data flows between these functions. So down here we are calling the fruit processor function with the arguments 2 and 3. And as we already know, this will then replace the apples parameter in the function with the number 2 and the oranges parameter in the function with the number 3. So that should be nothing new at this point, right? We are simply replacing the parameter placeholders with the actual values 2 and 3. And now let's analyze what's going to happen with these apple value. So apple right now holds the number 2. And that value 2 will then be used to call the cut pieces function, right? Now, as we call cut pieces, this 2 is actually the argument for the cut pieces function. And it will basically replace the fruit parameter, so the fruit placeholder. Okay? So now fruit here in this cut pieces function is also 2. And I hope that these arrows here make the data flow quite obvious. Then inside this function, of course, the fruit is then also 2, which will get multiplied by 4. And so the result here is going to be 8. And so the result of calling this cut pieces function with apples will be 8. And so that's the value that we then store into the apple pieces variable. And from there, we will then build this juice string that we have down here. Okay? So take a moment and analyze exactly how the data flows from one function to another, because I know that it can be a little bit confusing, especially calling the cut pieces function here without a tangible number. So we're calling cut pieces here not with an actual number that we wrote ourselves, like 2 or 3, but really with the argument that we received into fruit processor. So that can be a little bit confusing, so take a second to understand exactly what happens here. And what happened here with the apples variable will of course happen exactly the same with oranges. And so I'm not going to go into that part here, because that would be too confusing having all these arrows here on the slide. But of course you can analyze that for yourself and see exactly what is going to happen. But now let's move back to the code to see how this actually works out in practice. And so now we need to change this juice string here. So in the function that we just saw, it was already complete, but let's now write that out ourselves. So here we used to have apples, but now we want to use the apple pieces value. So apple pieces, piece of apples, and then here we want orange pieces of orange. So orange and apple here. Okay, so here we call the fruit processor function then, just as I explained in the slide. And then let's simply log the result to the console. There is no need in this case to store it into a variable. Okay, and so again, this works because the result of calling this function will become this string here that we return from the function. And so then console.log works with that string. So let's try that. And indeed, we get a juice with 8 pieces, which is 4 times 2 here, and then 12 pieces of orange, which is 3 times 4. And so that works just as expected. Great. So I think that was a really great example to illustrate this mechanics of one function calling the other. But now again, you might ask the following question. Why not simply multiply both of the input values by 4 and call it a day? So we could do that, of course. We can say apple pieces equals apples times 4, and orange pieces here is oranges times 4 as well. Well, but we did it this way for, well, multiple reasons. First, the point that I'm making here is that it's very common for one function to call another function. So just like we did here. And second, this is also a very good example to illustrate the don't repeat yourself principle that I mentioned earlier. So the dry principle. For example, imagine that suddenly the cutting machine would cut in 3 pieces and not in 4 pieces. Then if we didn't have the separate cut fruit pieces function, we would have to change the code in multiple places. And this is not a problem, of course, with 2 lines of code. But if we needed to cut like 10 fruits into pieces, then we would have to change that in all the places, and that would simply be annoying, and it could also be a source of bugs, so of coding mistakes. And so it's a lot better to put that functionality into its own function. So if the fruit was now only cut in 3 pieces, all we have to do is to change it here, and that's it. Then this changes to 6, which is 2 times 3, and this changes to 9, which is 3 times 3. Okay? So I hope that made sense to you and that you can start internalizing this kind of logic. With time and practice, you will exactly know when you should create your own functions and when to have multiple functions, one calling another. Great. Once more, congratulations for all the progress that you're making here. Working through these lectures about functions can be a lot of work, I know, and it can be sometimes a little bit confusing. So you're making great progress, and it's great to see that you're already at this point of the course. So again, functions is a very important topic, and so in the next video, we're going to take a couple of minutes to review the fundamental principles about functions that we just learned here. So stay tuned for that one, and I see you in a minute. To finish this part about functions, let's review everything important that we learned so far, in order to make sure that you really understand functions before we move on to other topics. And let's start by bringing back and rewriting the function that we wrote before, which is the years until retirement function. So I think that was, it was here in the lecture about arrow functions. So let's copy this one and paste it here. And the first thing that we're going to do is to actually convert it to a more normal function expression. So how do we do that? Well, in this case, we simply get rid of the arrow here and then write the function keyword here. And so now this is just a regular function expression like we learned before. Next up, we could export this functionality here into another function. So like a calc_h function that we've been using before. So let's do that, because then we can do what we did in the last lecture, which was to call one function inside of the other function. So let's write another function expression here, calc_h equals a function, and then the birth year again. And what we return from this one is simply 2037 minus the birth year. So we already did that before, right? Now you might find it confusing that we have two different functions here with the same parameter names. So this one has birth year and this one has 2, but that's not a problem at all. So this birth year in this function is not at all related to this birth year in this function. They are two completely different parameters, so basically two different variables. We could even have a variable outside of any of the functions, which could also be called birth year. Okay, and we could do that now, but I don't want to confuse you even further. Okay, but what matters here is that this parameter is really like a local variable to each function. Anyway, let's now go ahead and delete this here, and instead calculate the age based on the function that we just wrote. And actually we just delete this part here. And so now the age will come from the function calc_h, and what we pass in here is the birth year. So again, it's confusing now with these same parameter names here, but let's quickly call this function just so I can quickly show you the data flow. So years until retirement with birth year 1991 and first name of Jonas. So 1991 will be the birth year here in this function. Then as a first step, this years until retirement function calls calc_h. And it calls calc_h with the argument of 1991. So this one here. And so then birth year in this function also becomes 1991. And so then here the operation will be 2037 minus 1991. And if you find it less confusing, we could change this year to something else. Let's just say year, and it would work the exact same way. Okay, so again, these variable names in these two different functions, they do not have anything to do with one another. All right, but let's actually put it back here because it's good to keep this in mind. Down here, let's actually go back to returning a number and not this string, which for now I will just comment out. So here we call this function, and once more, I'm not going to store it into a variable. So we will just log the result of this to the console. So this should be just like before, 19. Okay. But now I want to show you something, which is to call this function again. Let's say now with Mike, and let's say Mike was born in 1970. And so his years until retirement will be 2. So a negative number, which means that he already retired. So let's quickly account for that. So what we will do is to basically return this number if it is above 0, and if it is below 0, we are going to return something else, like -1 or something, or some special number. So instead of returning simply the retirement, let's take a decision here based on the retirement value. And so that's something that we learned in the last lecture. So let's use an if-else statement and say, if the retirement is greater than 0, so if there are more than 0 years left until retirement, then return this retirement value. Okay? So remember that in the if block, we can put any code that we want. And so that includes the return statement. And else, well, let's just return always -1. So -1 is kind of a standard number in programming. We could also like return like this. So a number that shows us clearly that this has no meaning. Let's just keep it at number 1, minus number 1, okay? And I'm returning actually numbers here and not a string as we had before, because that's usually what we do, especially when we actually receive a number as an input. So here in this function, we get birth year here as an input, and it's a number, and therefore it's a good practice to then also return a number. Okay, let's try this again. And I would even change it to something more drastic. So 1950. And let's see what we get now. Yeah, so it's -1 now. Great. Now, one thing that I didn't mention yet is that this return keyword here will actually immediately exit the function. So it will first return the value that we tell it to return. So in this case, the retirement value. And then after that, the function is done. So it exits immediately. And we also say that the function has returned. So let me actually demonstrate that to you. And what I will do is to take this string here. Now we can get rid of the rest. And I will put that after the return. So we will log to the console this string here that we just had. And then here, let's log simply the first name has already retired. And then we can put another emoji here, like this party emoji that I like. And yeah, what do you think will happen when we run this code now? And keep in mind that we have the return before the console.log in both cases. So in the if block here and also in the else block. So what do you think is going to happen with these console.logs? Well, let's see. And indeed, they are simply ignored. So they will not get executed because, as I said before, the return statement immediately exits or immediately returns the function. And so therefore, there's no chance that this code here is even reached. So if we want this one here to execute, we need to put it before the return. And in VS Code, I can simply hit Option or Alt up. Okay, and that will then move the line up. So we also have that here somewhere in this menu. So that's move line up and move line down. So just so you see which one is the shortcut. So I use that one all the time. I also use add cursor below all the time. And I also use add next occurrence. So that would be Command or Control D. So what this means is that we have, if we have this, for example, here selected, then we can already see all the other ones. But if we hit Command D, then it will actually select that. So you see, now we have these 4 selected. And so we now could replace all of them at the same time. For example, like this. Okay. But anyway, let's go back to what we were doing here. So I just moved the console.log before the return here. And so now there should be a chance that the console.log is actually executed before the value is returned. And so let's do the same here. So again, I'm hitting Option or Alt up. And so these 2 lines changed position. And now, now it works. So we get the string, and here we get Mike has already retired. Okay, so this was to show you some more things about functions that we had already learned, and also show you something new, which is the fact that the return statement here immediately exits the function. So we reviewed already some things here, but now it's time to really review everything that we learned so far about functions in these first couple of lectures. And here we have the 3 types of functions that we talked about. So we have first the function declaration, and one particularity about function declarations is that they can be used before they are declared in the code. Second, we have the function expressions, and they are essentially function values that are stored in a variable. And finally, we have arrow functions that are in fact also function expressions, but special ones. And these are great for quick one-line functions where we don't need to explicitly use the return keyword and no curly braces either. I also said that this one has no this keyword, but more about that in one of the future lectures. Now, what's important to note here is that these are 3 different ways of writing functions, but they all work in a similar way. So all of them can receive input data, they transform data, and then they can output data. It's all optional, but usually that's the things that functions do. And no matter which type of function we use, we can always do these 3 things. And now let's zoom in a little bit further and take a close look at the structure of a common function, let's say. And this one here is a function statement, but it works the exact same way for all other types of functions again. So first, usually a function needs a function name. So calc_h in this example. Then a function also has parameters. And these parameters are essentially placeholders that receive input values. So as I said before, these are a little bit like local variables of a function. So variables that are defined only inside of this very function. Now, as you also already know, we use functions to reuse pieces of code. And these pieces of code are inside the function body. So this is where the function's input data is usually processed and then returned. And speaking of the return, by the end of the function, we usually have a return statement, which we use to output a value from the function. And also, as I mentioned a little bit earlier, the return statement also immediately terminates the function's execution. We also say that the function returns. Okay, and now about calling the function. We do that using parentheses. So we write the name of the function like we did here with calc_h, and then with the parentheses, we call the function. Because without the parentheses, the function is really just a value. But then with the parentheses, we actually call the function. And we can also say that we run the function, or invoke the function, or execute the function, and all of these terms kind of mean the same thing. Now in this case, since the function actually has parameters, we then call the function with arguments. And these arguments are the actual values of the function parameters. So we use these to input the actual data into the function. And we can also imagine this as replacing the placeholders that are the parameters. Then, once the calc_h function has finally done its job, then all this expression will basically be replaced with the returned value. So in this case, the h that was replaced here. And that h value is what we then store into this h variable. So we use this variable to basically save the returned value that was outputted from the function. Okay? Now, just one other thing that I want to make clear is that this console.log that we have in the function, so in that first line there, has nothing to do with returning a value. This simply prints a message to the developer console, but it has nothing to do with returning. So actually, the console.log is actually just another function call inside the calc_h function, because console.log is itself a function. And so the argument that we pass into the console.log function is what will get printed to the developer console. Okay, so just wanted to make sure that you really get this distinction between console.log and return. The reason why we always use console.log is because we want to see the results of our experiments in the developer console in the browser. Anyway, I think this pretty much sums up all there is to know, at least for now, about functions. So make sure that you got all of this down, and then you can move on right to the next video, where the first coding challenge of this section waits for you. And as you can probably guess, it's going to be about writing your own function for the very first time. So I hope to see you there soon. Welcome to the first coding challenge of this section. And as you can imagine, this one is going to be all about functions. And we're back to the two gymnastic teams from the previous section, the dolphins and the koalas. And now there is a new gymnastics discipline which works in a bit different way. So now in this new discipline, each team competes 3 times, and then the average of the 3 scores is calculated. So each team will get 1 average score. And then a team only wins if it has at least double the average score of the other team. And otherwise, no team wins. So sounds pretty simple, I hope. And let's take a look at your tasks now. So first, create an arrow function called calc_average, which calculates the average of 3 scores. And actually, this calc_average function should be able to calculate the average of any 3 values. So of course, the values don't have to be scores. Any random numbers will work just the same. So this is basically a generic function just to calculate the average of 3 values. Then use that function to calculate the average for both teams. And again, down here, you have the test data that you can use. Create a function called checkWinner, which takes the average score of each team as parameters. And these parameters should be called average dolphins here and average koalas. And then, based on these 2 average scores, the function will log the winner to the console together with the victory points. And that, of course, needs to happen according to the rule that I just explained before. So a team only wins if it has at least double the average score of the other team. And otherwise, no team wins. So you need to check for that condition in order to print which team wins. And in some cases, no team might win at all. So you need to account for that as well. So here in point 3, you write the checkWinner function. And then in number 4, you will use, so basically you will call the checkWinner function in order to determine the winner for both the test data 1 and test data 2. Okay? So I have some hints again, but if you want to try it on your own without the hints, then just pause the video right now. But if you need the hints, then, well, here they go. So this one is probably pretty obvious, which is to calculate the average of 3 values, add them all together, and divide by 3. But the second one here is a little bit more important and maybe more difficult for you to figure out on your own. So to check if number A is at least double number B, what you need to check is if A is greater or equal 2 times B. Okay? And so this is what you will use with the team's average scores. Okay, so it's important to keep this one in mind because of this rule that the team only wins when it has double the average score of the other team. All right. Now, please make really sure that you understood everything I showed you about functions before you attempt this challenge, because this one is not so straightforward. And so I don't want you to get frustrated. So again, please really make sure you understand functions and only then attempt to do this challenge. But if you feel that you're ready, then just pause the video now and good luck with this challenge. All right, so let me show you my solution to this challenge, which I hope, of course, you were able to do on your own. So I'm going to start with the calc average function as in number 1. And remember that this should be an arrow function, and it will receive 3 values so that it can calculate the average of these 3 numbers. And here I'm actually just going to call the 3 numbers A, B, and C, because again, this is supposed to be just a generic function which can calculate averages of any 3 numbers. It doesn't have to be any scores. And so ABC are just generic variable names. But of course, it's totally okay if you used more specific variable names. So adding all the 3 numbers together and then dividing by 3. So this one is nothing new. This was just to basically test your knowledge of the syntax of the arrow function. So what's important to notice here is that we need the parentheses here because we have multiple parameters, but then here we only really have this line of code. And so therefore, we don't need to even write the return. This value gets automatically returned from the function. And now let's just test it out before we move any further. So calc average, and then let's just use some random numbers, because here we know that this is supposed to be 4, right? So we have 3, 4, 5, and so the middle one here is the average between these 3. And indeed, it is. And so we know that our function works. And so we can move on to point number 2, which is to use the function to calculate the average for both teams. So let's say score Dolphins is equal to calc average. And now we pass in the specific arguments for the 3 parameters A, B, and C. And so for test data 1, which is this, so let me actually write that here, test 1. So for the Dolphins, we pass in the values 44, 23, and 71. Then for the koalas, it works the same way. So score koalas equals calc average. And now we have 65, 54, and 49. So nice reusable function right here. And so having this function, we don't need to calculate it here manually every single time. So that's really great. So we can really appreciate the fact that, again, a function is really like a machine in some sense. So it doesn't care where the inputs come from and where they go. All it does is to calculate the average of 3 numbers, no matter if it's scores or heights of people or money or whatever it is. So this function really is kind of isolated from the rest of the code here. It's a standalone function that we can then use for our own purposes. And that might sound pretty obvious, but it's actually important that you really internalize this aspect of functions. Only then can you really start to see the potential for functions everywhere in your code. Anyway, with that being said, let's now log these values to the console, because I always like to see what I'm doing. So this part is of course not mandatory, but it's also nice to be able to know these scores so that we know if the logic that we're going to implement next is working correctly. So we see that in this case, the koalas have a score that is higher than the one of the dolphins, but it's not double. And so we already know that in this case, no team should be able to win. But let's now actually implement that functionality. So that's the function check winner. And so it takes the average dolphins and average koalas parameters, okay, and then it logs the winner to the console. So let's do that. And once more, it's no problem if you did this differently. If you made it work, then it's great. So average dolphins and average koalas. And now all we need to do is to check whether the dolphins won or the koalas won, or if no one won, basically. So when do the dolphins win? Well, they win if they have double the points of the koalas, right? That's the condition. So again, a team only wins if it has at least double the average score of the other team. And so that's why I told you here in this hint that this is how we check for that. So A has double the amount of points of B if A is greater than 2 times B. So let's do that. So average dolphins greater or equal to 2 times the average koalas. And in this case, we log to the console dolphins win the trophy. So let's use an emoji here again, but you don't need, of course, to do that. So it's already here. And now it also told us to put the points. So, for example, 30 versus 13. So both points with the verses in between. So that's average dolphins versus average koalas. So you see that here we are also practicing all the other skills that we already acquired before, especially in the previous section, right? Okay, and now here we just need to do the opposite. So else if, and now if the koalas have at least, so that's basically what this one here means. So greater equal is basically at least. So if average koalas have at least double the points of the dolphins, then the koalas win. So let's just grab this one from here. Koalas, and here it's average koalas and then average dolphins. Average, yes. All right. And now in any other case, we say that no one wins. So I think that's also said in the rules. Yeah, that's number 5. I think I even forgot to tell you this one, but hopefully you read it. So you should ignore draws in this exercise this time. So if none of these is true, we simply say that no team wins. No team wins. Okay. And now all we need to do is to call this function here. So check winner, and we will do that with score dolphins and score koalas. Okay, so let's recap. We calculated the score of the dolphins up here and of the koalas as well. And now we call the check winner function here, okay, and we use as arguments the scores that we calculated before. And then score dolphins will become average dolphins here in this function, because that's the name of the parameter. And I see that I misspelled this, and so now I can use that Command D that I talked to you about before, so I can select all of them. So Command D, Command D, Command D, Command D, and now I can use all of these cursors here at the same time. So dolphins. You see, I inserted the P in all of the variable names everywhere. All right. And so now this parameter name here gets used for all these calculations. And again, originally this value comes basically from here, from calculating the average of these three scores. So this average gets stored here, then we use it here, and then it gets basically transferred to average dolphins and is then used everywhere in this function. Okay, so let's now test. And as we expected, no team wins, because this team here, even though it has more than the dolphins, it's not double. And so therefore, they do not win. Now, of course, what is also important to mention here is that this check winner function here is also completely independent of these score values that we calculated earlier. So here we can simply call this function with completely different values. So the function doesn't care where these values come from. So where average dolphins and average koalas come from. It's a standalone function and it doesn't care at all where these values came from. We can just plug in some random numbers here and then call it. And let's use a smaller number here. Okay, so just so that the average dolphin here is actually more than double of the average koalas. So if we run this now, then we see that the dolphins win with 576 versus 111. And so that's exactly the numbers that we plugged in here. Okay, so once more, it's important to keep in mind that these functions are all independent from another. We just happen to call check winner here with these values that we calculated before. But it's not mandatory to do that. Any other values will work just as well. And so we proved that here. Anyway, now let's use test data 2. And actually what I'm going to do is to reassign these two scores here. So we calculate them first, then we call check winner, and then I'm going to recalculate them and call check winner again. So what I mean by saying that is that these need to be let variables so that we can reassign them. Remember that? Const values cannot be mutated. They cannot be changed. And so they need to be let. And then here, of course, we need to get rid of that let because we do not want to create new variables. We just want to overwrite. So we want to reassign the values that we had earlier. So this time the values are 85, 54, and 41. 85, 54, and 41, and I hope that's correct. And then for the koalas, we have 23, 34, and 27. So that's 23, 34, and 27. Let's log these actually also, and then simply call check winner again. And now with the new values of score dolphins and score koalas that we just reassigned. Okay, so let's see. And now the dolphins have an average score of 60 and the koalas of 28. And so now the dolphins win with 60 versus 28. So that's a close call. So if the koalas had 3 more points, then no one would win. But the dolphins managed to do it. Great. So I hope that this all made sense to you. And I know it is probably still a bit confusing at this point. And if you did some things differently, well then, once more, that is completely okay. It just means you're developing your own coding style over time. For example, here with the average scores, of course, you could have created new variables down here for the test data too. So that's just one of many things that you could have done differently, which are perfectly fine. As long as your results are the same, you're good to go. So take some time and review this lecture. Remember that you can check out my final code also in the final folder in the GitHub repo. And then you're ready to move on to our next big topic in this section, which is going to be arrays. So I hope to see you there soon.